Hi guys, in this problem, your task is to describe the local and end behavior of the function. I think the end behavior of this function is pretty straightforward. Uh, End behavior means the horizontal asymptote. So how do you find the horizontal asymptote? You quickly simply just look at the power, okay, look at the power, and then that's my hint. So I would like you to go back and check your notes and see how you can do what you should do to figure out the end behavior, which means when x is approaching infinity, what is y approaching. Now as far as the local behavior, um, my suggestion is, first of all, factor this guy, x minus 3, x minus 1 on top. The bottom is x minus 5, x plus 1. Okay, so in other words, I know two vertical asymptotes because they don't cancel. I know what, therefore I have two vertical asymptotes, and then these two vertical asymptotes are, one is -1, the other one must be 5, right? Where are they from? They're coming from here, 5, and the other one -1. Now, because they're both power 1 here, I know uh, the when the both if a number approaching this vertical asymptote from both sides, they should go into the same direction. I mean opposite direction. So here this 5, I know this shape is like that. The reason is because any number greater than 5, you plug this in, it will be positive, so it must be above that. Now because this power is 1, I know this has to be different direction. When this goes up, this should go down. Similarly, I know on this side the graph should look like this. Okay, should look like this. The reason is when x is negative, a number negative, less than -1, if you plug in this x here, they're all uh, I will have 4 negative numbers, which turns out to be positive. So I know on this side the graph should be above x-axis. So let me describe what I meant. So imagine when x is -2, somewhere here, -2, right? If you plug in this function, so -2 minus 3 will be -5. -2 minus 1 will be -3, divided by -2 minus 5 will be -7, -2 plus 1 will be -1. Do you see I have 4 negative numbers? It will be a positive number. So that's why I know it should be above the x-axis, this graph. Now because this power is also 1, I know when this side is going up, this side must be going down. So therefore the basic shape is something like that. Okay, something like that. So with this, I can discuss the local behavior. Let me take a look at the first one. When x is approaching -1 from the left, this means from the left, f of x is approaching infinity. Seems like okay because that's what I see. When x is approaching 1 from the left side, this graph is going up, right? Going up. So this is okay. When x is approaching 5 from, this plus means from the right, f of x is going up. So that's exactly what I see right here, right? When x is approaching 5 from the right, it goes up. It goes up. Now let's continue to read. As x approaching -1 from this plus sign from the right, f of x goes to -infinity. So let's check. When x is approaching -1 from the right, this graph is going down, which means going to -infinity, which is good. When x is approaching 5 from the left, this answer says f of x is approaching infinity. Now when x is approaching 5 from the left, I see that the graph is going down. So therefore this doesn't match, right? This doesn't match. So I'm not gonna choose this guy. So now I think that with this discussion you should be able to choose the correct answer. So here's another hint. Uh, if you are not able to do the discussion like what I did, I factor and then discuss the sign so that I create the graph of the function, right? So I would like you to graph this function in decimals, and then once you identify those two vertical asymptote, I suggest you to type that in x equals -1 and x equals 5 so that you see those two vertical asymptotes. It will help you identify those local behavior. And then when you see that as x approaching -1 from the left, you know this guy is approaching infinity. So this graph should help once you have that. Okay, this is the hint for this particular one.